Example 6. The table shows the distribution of grades of students for a certain subject in an examination. Find mean, mode, and median. To find mean, we need to find total of F times with X first. So it's gonna be 7 times with 1 plus 13 times with 2 plus 9 times with 3 plus 7 times with 4 and so on plus 1 times with 9. So the answer is 159. To find total of frequency, we have to total up all of the number of students here to get the answer, which is 48. So the mean is equal to 159 over 48, which is 3.313. To find mode, we need to look for the most frequented data, which is in our case is 13 times repeated. So the answer is 2. The grade 2 is our mode. To find median, it's actually equal to P50, which is half of the data. So S is equal to the number of students 48 times with 50 over 100. So we'll get the answer as 24. So the median is equal to the 24th observation plus with the 24th observation over with 2. So in our data, this is 7, this is 20. It means that 24 is going to be here. This is for the 21st data until 29th data. So our data for the 24th is 3 plus 3 over 2, which is 3. For the next question, we need to look for first quartile, third quartile, and P12. So for the first quartile, S is equal to 48 times with 25 over 100 equal to 12. So Q1 is equal to the 12th data plus with the 30th data over 2. Sorry, 13th data. So we'll get 2 plus 2 over 2 is equal to 2 as our Q1. For S, for the third quartile, 48 times with 75 over 100 and we'll get 36. So Q3 is equal to X 36 plus X 37 over 2. So the 36 data and the 37 data is 4 plus 5 over 2. To find P12, S is equal to 48 times with 12 over 100 and we'll get 5.76 and it's not belong to the integer, so we have to find the least number bigger than 5.76, which is 6. So P12 is equal to the 6 data, which is in our case, if I show you, one of them is gonna be 1, because in this first column, this is for the first until the 7th data. So we know that our data for P12 is equal to 1. The next one is standard deviation. So total of fx square is equal to 7 times with 1 square plus 13 times with 2 power of 2 plus 9 times with 3 power of 2, and so on until the last data, which is 1 times with 9 power of 2, to get the answer as 693. So the standard deviation is actually 693 minus with 1 over n, which is 1 over 48, times with the total of fx, which is 159 power of 2, over with n minus 1, which is 47. So we have to put set to all of this to get the standard deviation, which is 1.881.
Construct the box and whisker plot. Hence, state the shape of the distribution. First, we determine the lower fence by using the formula. So 2 minus 1.5, 4.5 minus 2 equal to negative 1.75. Next, for upper fence is 4.5 plus 1.5 times 4.5 minus 2 is equal to 8.25. The maximum value is 9 and minimum value is 1. First, we draw the position of Q1 is equal to 2. Then for median or Q2 is equal to 3. Then for Q3 is 4.5. We draw the box here. Then we determine the location of lower fence, negative 1.75. Also for upper fence, the value is 8.25. Since we look at to upper fence is 8.25, then we have the value is bigger than upper fence, means 9. So 9 we call as a outlier. Then we draw for Q3 to the maximum value before upper fence is 8, and draw Q1 to the minimum value is 1. From the box and whisker plot that we have, we can see that the right side is longer than the left side. So the distribution is skewed to the right. Example 7. Given the two data as listed below, data 1 and data 2, find the mean and standard deviation for the above data and interpret the value obtained. First, for data 1 and data 2, we should find the sum of x. Sum of x for data 1 is 143, and also for data 2. Then To find the mean is sum of x over with n. So mean for data 1 is equal to mean for data 2. Then, to find the standard deviation, we find the sum of x squared for the both data. For the first data is 1957, for second data is 2307. Then, by using the formula, standard deviation for data 1 is equal to 3.13 and for data 2 is 6.69. Then, we can say that the standard deviation for data 2 is greater than data 1. Therefore, the data 2 is more dispersed and less consistent compared to the data 1. Example 8. The following is the systolic blood pressure in millimeter Hg of 10 patients in a hospital. Find the mean and mode. Describe the shape of the distribution. First, we determine sum of x. Sum of x is equal to 1499. N is equal to 10. So mean is equal to 1499 over 10 is equal to 149.9. Then for mode, we refer to the data. The most frequently occur is 146. So mode is equal to 146. By using two values, mean and mode, we can write mode is less than mean. Therefore, the distribution is skewed to the right. B. Find the standard deviation of the systolic blood pressure of the 10 patients. Hence, find the Pearson's coefficient of the skewness. Comment on the distribution. To determine standard deviation, we need find sum of x squared. Sum of x squared is 226,397. Standard deviation S is equal to square root of sum of x squared 226,397 minus 1 over n is 10 times with sum of x squared 1499 square over with n minus 1 is 9. So, S is equal to 13.731. To find the Pearson coefficient of the skewness, we use the formula SK is equal to mean minus mode over standard deviation. So mean is equal to 149.9 minus mode is 146 over standard deviation is 13.731 and this is equal to 0.284. By refer to the table for SK, therefore, the distribution is skewed to the right. Find the number of patients whose systolic blood pressures exceed 1 standard deviation above or below mean. First, we rearrange data in ascending order. Then, we look at to the value of mean. Mean is equal to 149.9. Standard deviation is equal to 13.731. So, to determine the patient whose systolic blood pressure exceed 1 standard deviation above or below mean is for above plus with 13.731, for below 1 standard deviation minus 13.731. So the range in between 136.169 and 163.631. We can see here the number of patients with systolic blood pressure outside the range is 3, means 124, 135 and 173. So we write the number of patient with systolic blood pressure outside range is 3.